The first law of thermodynamics teaches us that heat cannot be created or destroyed, but it can be moved. The refrigeration cycle leverages this law by moving heat from an area or object where it is unwanted to somewhere that it will do no harm. In a refrigeration cycle, the condenser is the heat exchanger responsible for rejecting the heat gained in the evaporator and compressor. Most often, the heat is expelled into the atmosphere, but other heat-receiving media can be employed as well. A refrigeration condenser receives high-pressure superheated vapor from the compressor. As the refrigerant passes through the condenser, its temperature is lowered and the vapor is cooled. Once the refrigerant becomes saturated, it continues to reject heat, but now in the latent form as vapor transitions into a liquid at a constant temperature. High-pressure saturated liquid exits the condenser and enters a high-pressure receiver or is piped directly to an expansion device.
When I'm teaching students about refrigeration, I always like to challenge them on a specific component, like what if that component wasn't there? So for example, what if there was no condenser? To get them thinking, okay, how would that affect the exchange of heat throughout the system? So if we removed our condenser from the system, well, the compressor is going to increase the pressure and temperature of the refrigerant vapor up to a high level, and then normally it goes to the condenser. If that's not there, it bypasses that and goes straight to an expansion valve. Well, now we can see our problem. We have vapor, hot vapor going to an expansion valve. It's not going to do us any purpose, no purpose in a refrigeration system for that. So that's one way to challenge yourself as you're preparing or learning about refrigeration, is to ask yourself that question.
There are three primary categories of refrigeration condensers: evaporative condensers, water-cooled condensers, and air-cooled condensers. Evaporative condensers use a combination of air and water to cool the refrigerant, which results in lower condensing pressure and efficient operation. Water-cooled condensers utilize a heat exchanger with cooling water that is pumped from a remote cooling tower. The water absorbs heat from the refrigerant and is returned to the tower, where the heat is rejected to the atmosphere. Air-cooled condensers are the simplest type of condenser and use fans to move air over the condenser coil's surface. No water is employed in an air-cooled condenser. This results in the highest condensing pressure of the three categories. Historically, air-cooled condensers have been limited to residential and commercial refrigeration systems, but are gaining popularity in low-charge ammonia systems because of their simplicity.